Okay, the next lesson that we want to go over is 372. 372 is also fairly simple. It will get much more complicated as you get further into the year because we'll keep coming back to this concept and adding some things to it. But we're going to take a very easy approach to it right now. We're going to focus on one specific thing. It's important to understand the relationship between a function and the graph of a function. In this lesson, we'll explore how a function and its graph change when a constant value is added to the function. Okay, we're going to call this a vertical shift. Okay, it's a type of translation that moves our graph up or down depending on the value that's being added. A translation of a function can happen vertically, horizontally, or both without changing the overall shape. So this is called a vertical shift as a type of translation. In this class, you'll learn eventually about translations, reflections, and rotations. Okay, so like I said, today we're going to focus on just one of those pretty much and talk about vertical shifts, which is a type of translation. All right, a translation can also be called a slide or a shift. So slide and shift are interchangeable here. And a translation is a specific type. A translation is a specific type of transformation. A transformation moves your graph in some way. In other words, it changes the equation to move your graph to a different spot. Transformations can include reflections and rotations in addition to translations. We'll examine the translations of a graph and determine if they're similar or different. Okay, again, it sounds complicated. That's why we're going to focus on one little piece of it today so that it's not too overwhelming. All right, so key concepts. Vertical translations can be performed on linear exponential graphs using this notation right here, where k is a value that's being added or is the value of your vertical shift. Vertical shift just simply moves the graph up or down k units from wherever it was previously. If k is positive, then the graph is translated up k units. Basically, you take every point and move it up k units. If it's negative, you take it down k units. That would be denoted by minus k instead of a plus k. Translations are only one type of transformation, so make sure you nail this one down because we're going to add to it eventually. Given the graphs of two functions that are vertical translations of each other, the value of the vertical shift k can be found by finding the distance between the y-intercepts. So that's going to be important. If it's just a vertical shift, you can simply subtract the y-intercepts to figure out what change was made. All right. So let's get to some examples. All right, so this looks complicated. Don't freak out on me. It's not that bad. So we have four functions here. They're all graph. We have f of x. I'll do this. We have f of x equals 3x. We have f of x, g of x, which is 3x plus 1. We have h of x, which is 3x plus 2. And then we have 3x minus 1. So what I'm going to do first is I'm going to go down here and I'm going to figure out which one's which. Now, they've already kind of marked them for me, which is nice. But f of x equals 3x. So we go through 0, 0. And we go up 3, right 1. Okay? So this line right here is my f of x, right? That's why I did it in red to match. Now, how are the others related to it? Well, let's look at the green one. Let's look at g of x. What did you do? What did we do to g of x? We took the original function and we added one to it. So g of x is actually f of x plus 1. Because remember, f of x is simply 3x. So we just replaced that back, right? So we took the f of x function, which we already have graphed in red, okay, and we added one to it. We added that k value. So we shifted a vertical shift up 1 unit. So basically, we take all those same points that we just had, which was here and here, and we push them up 1 unit to there. And now I have, and you can't see the one there, but that's okay. Because now I have the same line, parallel, right? But it's 1 unit higher. Okay? The same thing is going to be applied for this one, h of x. H of x is f of x plus 2. Or we could also say that it's simply g of x plus 1, right? Depending on what you're using as your starting equation. So that gets shifted. That gets shifted up 2 units from where we started. So 0, 0 is now here. And we still have the same slope. Notice it does not affect my slope. It only affects my y-intercept. Okay? And then lastly, the last one here, if I had done q of x, that would be the original f of x minus 1. So we started our f of x spot, and we go down 1 unit, and we keep that same slope. And that's our equations. That's our lines. Okay, so it's just a vertical shift, and we do that by adding or subtracting a number on the end of the equation. Basically, changing the constant for a linear function. Okay, so hopefully that's pretty straightforward. Let's look at the next example. All right, the next example. Given that f of x is 2 to the x power plus 1, okay, and the graph of f of x is shown below, graph g of x, which is f of x minus 5. So using the notation that we've already done, all I have to do is simply realize that g of x is the f of x function that we already have shifted down 5 units. So we take each point and shift it down 5 units. So here's the first point I see. So if I go down 5, 1, 2, 3, 4, 5. Okay. And now I don't really have any nice points over here on this left side. Okay, but it does appear that we have an asymptote at the line below our y-intercept. So we're going to have an asymptote at -4. My new asymptote is -4. Okay, and now on the other side, the next nice point I kind of have is 2, 5. So if I shift that down 5 units, 1, 2, 3, 4, 5. That will be there. Okay. And now I want to see if I have any other nice. Yes, I do here. So that's 3, 9. So down 1, 2, 3, 4, 5. Now with an exponential, what you're going to notice is it doesn't look like a perfect shift, because with the linear, it would stay parallel. Well, these can't stay parallel because of the rate of change being different. So what happens is the further out you go, the actual closer these things appear to run to each other. They don't run exactly next to each other, but they get very close, or they appear to get very close. So this area in here, where the curve is happening, that little section there is where you're going to notice the shift most effectively. Which is why we mentioned again, focusing on those y-intercepts. Okay? Because if you look out here, you look in this area up here, you look there, you're not going to be able to really see the shift that's taking place. Now, the other thing that we can do is this. Since f of x is 2 to the x power plus 1, right, and then g of x is f of x minus 5, what I really want to do is use my lesson 3.71 to realize that g of x is actually 2 to the x plus 1 minus 5. Okay? So that original f of x function, and then subtract 5. Well, I can combine like terms and realize that g of x is simply 2 to the x power minus 4. Which again, we talked before, the hint was that that's your asymptote. Okay? That's your asymptote. Which, as we can see, for the blue line down here, my asymptote is indeed -4. Alright? Let's keep going. Graph the two functions f of x and g of x shown below. Write a rule for g of x in terms of f of x. Well, I don't know what f of x is, but I can do this. G of x equals f of x plus or minus something, because I can see that they're connected, right? So this is g of x, and this is f of x. So the first thing I should realize is that f of x is obviously above g of x. So we need to add something to f of x to get to g of x. The question is, what are we adding? Well, how far above it is it? So focus on your y-intercepts, or really any point since it's linear. And you can any point for exponential too. It's just that intercepts usually are the easy ones. So we just want to figure out how far up we went. So 1, 2, 3, 4, 5, 6, 7. So f of x plus 7. Okay? Pretty straightforward if you have a problem like that. All right, that's the test. So that was all the examples. Like I said, I think 3, 7, 1, and 2 are pretty straightforward. Stop me, ask me